they can stand up to the toughest bully. Take over 50,000 slams without a single hinge breaking, and air out a rotting PE kit even when the door is locked. If you think 6 years of secondary school were hard to take, try 50. That's how long school lockers like these can last if they're built to take the abuse. Most school lockers are made of this, cold rolled steel. This type of steel is perfect for lockers because it's affordable, extremely durable, and even fire resistant. The steel arrives at the factory in huge rolls known as coils. A single coil weighs up to 4.5 tons. The only way to move them is with an overhead hoist. The steel is loaded onto a payoff reel that uncoils it and feeds it like a ribbon into a massive mechanical press. The cutting blade of the press bears down on the coil with a huge amount of hydraulic pressure, slicing it into the proper lengths for locker parts. In this case, it's cutting the front door panels for the lockers. A 180-ton press and a rectangular die punch a space in the center of the door. The space is for the recessed pocket that will hold the handle and padlock. Another 180-ton press punches out the vents that help prevent fungus and other microbes from growing in forgotten pairs of dirty gym socks. The vent press also crimps the tops and bottoms of the doors for assembly, while additional presses crimp the two sides. The angle of the fold is really important, because if the edges of the door are not flush, the locker won't close properly, let alone slam. Assembly of the door frames is already underway in another part of the factory. First, a worker welds 3 hinges to one of the pieces of the steel frame. The welder zaps each hinge with 95,000 volts of electricity. That's enough to melt the contact point between the hinge and the frame and fuse them into a single piece of metal. The bond is so strong, the steel itself will tear before one of these hinges pops loose. A worker loads the 4 pieces of the frame into a frame welder that zaps all 4 corners with another 95,000 volts, creating the same strong bond. The finished frame is now ready for the door panel. It's attached to the frame with rivets instead of a permanent weld. That way, a damaged door panel can be removed and replaced without replacing the entire locker. Once the doors are fully assembled, it's time to hit the showers. After a quick rinse and dry, the lockers move through a spray booth for a blast of paint. Schools can order any color they like. In America, they tend to be matched to the colors of their athletic teams or school mascot, while in the UK, we tend to be a bit more restrained. The paint itself is made of tiny particles of plastic resin that are treated with an electrostatic charge. The charge attracts the paint particles to the locker parts, the way a magnet attracts steel. The bond is made permanent inside an oven that melts the paint particles and fuses them to the lockers. The parts emerge from the oven dry and ready to be fitted with handle pockets with space for padlocks that lock the lockers once they're installed in a school. Finally, workers sort the locker parts into kits and ship them off to the school where they are assembled on site. Given how long these are built to last, it's possible that a locker installed for this year's new kids could still be around to see their grandchildren start school.